This video is going to take a look at configuring the ASA site-to-site VPN between two 5505 firewalls. We're going to basically just run through the configuration and see some verification steps to make sure that the clients are actually able to talk. And we're going to be focused mainly on the DSU side of the configuration here. So ahead of time, I went and configured the UC firewall. And by the end of this, we should be able to have our laptop 0 ping laptop 1, and they should be able to ping each other by their local or private IP addresses. So kind of accentuating the point of the VPN connection that we're making. Now, depending on the version of the ASA you have, the configuration is going to be slightly different. So this is going to be for the packet tracer 6.2 goes up through 7, so it's a pretty normal configuration. There's just slight different nuances between the newer versions of ASA. Also, the order that we do this in doesn't matter so much as we make sure that we do the crypto maps at the very end of it. So we can do our access lists, we can create our IKE v1 policy, we can enable it, do the transform sets and tunnel groups, and then we'll go back and do the crypto maps. So I'm going to jump right in. We have the IP addresses configured and everything, so let's start on the DSU campus VPN headend. So a couple things that we should probably do is just make sure that we can actually ping the peer that we're trying to reach. So 138.247.80.2, and that looks good. So from config-t, the first thing I'm going to do is create an access list that is going to identify which traffic should be passed over the VPN. There's a few different ways to do this, but I'm going to craft the ACL specifically to take TCP and ICMP traffic and push that over our VPN. So I'm going to make an access list, and I'm going to call this list VPN traffic. And we're going to identify it as an extended access list that we're allowing traffic from TCP and our inside hosts, so 10.0.0.0, and we just made that a slant 24 network. And anything from originating from 10 going to the 192.168.1.0 network, we're going to identify as what should be VPN traffic. So this ACL is not going to really do any blocking or anything like that. It's going to be used a little bit later on by the crypto map just to identify that traffic that should be sent over our VPN. Now I said we're going to do TCP. I also wanted to add in ICMP. So we'll just up arrow and replace TCP with ICMP. And we should have an ACL configured for that. Now the second part of this, we also need to create ACLs that are going to allow the remote users, so in this case the remote user being laptop 1, to send traffic in to our internal network to laptop 0. Now the traffic flows is going to come across their ASA through the DSL modem, across the internet, and hit our firewall on the outside interface. We need to allow the traffic to pass from that outside interface to our inside interface so it can reach that internal host. So our next ACL that we make, we'll just do another extended access list, and we're going to call this allow VPN traffic. So we said it was going to be an extended ACL, and we're going to permit any TCP traffic originating from the remote hosts, so 192.168.1.0, to our internal hosts, 10, and we said both TCP, and same thing here, we wanted to allow ICMP as well. So we just up arrow again, replace TCP with ICMP, and our allow ACL should be done. Now we know that an ACL does not do us any good if we don't actually apply it to an interface, so that'll be the last step of our access control lists. So we're going to use the allow VPN traffic ACL. We're going to say that traffic is going to be allowed out of the inside interface. And of course we have to spell interface correctly for that to go. So let's do a quick look at our running config here just to see what we have. And as we go down through, we'll find our IP addresses and the ACLs that we made. Now again, I just want to reiterate, these top two ACLs do nothing but identify traffic that should be sent over this encrypted tunnel. The bottom two, the ones that we just created, are going to actually permit that traffic to enter our network. The next thing that I want to do is create our IKE and ISACAMP policy. Now this is where I've seen some syntax differences between different versions of the ASA. The way we're going to do it here in Packet Tracer is we're going to create a crypto, and we're going to do IKE v1 policy with the priority of 10. In different versions of the ASA, we would do a crypto ISACAMP policy. Anyways, once we're in the policy, we can start to define how this ISACAMP tunnel and everything is going to work. So we're going to set up our authentication, we'll do our encryption, we're going to set up the Diffie-Hellman group 2, choose our SHA hashing algorithm, and we'll set the lifetime of those keys. So we'll kind of work down the set of steps here. As far as authentication goes, we're going to do pre-shared authentication. Some organizations, and it's not a bad idea, opt to do certificate-based authentication. For the sake of simplicity and the limitations imposed by Packet Tracer, we're going to stick with a pre-shared key exchange. As far as the encryption algorithm goes, we'll choose something very strong like AES 256. We also need to set our Diffie-Hellman group, so we'll do a group 2 is kind of the standard for this type of key exchange. The hashing algorithm that we want to use, we'll do SHA, it's a little bit better than MD5. And we'll set the lifetime of our keys to 86,400, so a pretty long lifetime for those keys to be valid. There shouldn't be anything else we really need to do for that policy other than to enable it. So let's back out, just straight from config T, and we'll do crypto IKE v1 enable on the outside interface. Perfect. Now the next piece that we're going to work on is creating the actual transform set. So really describing how this tunnel is going to use that authentication or the encryption algorithm that we chose, as well as the hash algorithm for those packets going across. So we're going to create the crypto IPsec. This is the IKE v1 transform set. The first thing that we specify is the name of the transform set. So we could do something like trans set. You could do L2L, just whatever naming makes sense for you. And the first thing that we're going to set up is the encryption that we're using. So we had chose previously ESP AES 256. And then we set up our hashing algorithm that we're using, so ESP SHA HMAC. Okay, so that is all we need to do for the transform set. Next up is the tunnel group, where we'll actually set up the pre-shared key that we're going to use between these two ASAs. So we'll do our tunnel group, and when we configure the tunnel group, the name is always your peer's IP address. So in this case, my neighbor is going to be 138.247.80.2, and the type of that is an IPsec L2L. Remote access would be things for like your any connected clients, the web VPN. In this case, we're just doing that site-to-site VPN, so we choose that. We set the attributes, and the only attribute we're going to have to set is the pre-shared key. So we're going to say IPsec attributes, and that'll drop us into actually configuring this tunnel group. And there's not a whole lot for us to do within here, so we'll just go right ahead into the IKE v1 pre-shared key, and I'll just choose something like Cisco 123. Okay, so we have really all of the pieces that we need to have put in place before we go through that crypto map. So we've set up our ACLs, we've applied them to an interface where appropriate, we've created the crypto IKE and ISACAMP policy, we've enabled that on the outside interface, we created the transform set as well as the tunnel group. Now what we need to do is use a crypto map to tie all of these pieces together, and that's going to help us establish this VPN tunnel. So everything happening through this crypto map is going to be starting out with crypto map, and we just give it a name. So I might choose something like crypt map, and our priority that we chose before was 10. And we start to fill in the blanks here. So we're going to match, and this is saying what traffic do we actually want to pass over the VPN. Well, before, one of our first steps was creating a ACL to identify that, so we can use the VPN traffic ACL. We need to do match, let's see, address, VPN traffic. Perfect. Our next set of commands are always going to start with crypto map, the name of it, the priority, and we'll go into the set of commands. So these three things are what we need to configure here. So we can just start down the top of the list. So we'll start with our IKEv1 transform set, and we called that trans set. The next thing that we needed to do is set our peer. So who is your neighbor that you're trying to connect with? And that was 80.2. We set the security association lifetime. This is how long we should go before like rechecking keys or making sure that we're still alive. So our security association will do the lifetime in seconds and just choose something like 7200 for that. Okay, so that's all we should really need to do for that. We have to also apply this to an interface. So applying this crypto map to the interface happens just like this. We'll do crypto map, give it the name, you can remove the priority for it. And we'll say this is going to happen on the interface outside. Now in Packtrace, I keep getting the crypto map has incomplete entries. Really, we don't have any more options or things to set up in that. So we're going to be fine with that for now. This still should connect and still should work. So the way we're actually going to check is this actually up is we'll do a show crypto ISACAMP security associations. And this won't actually show anything until we have traffic passing across our VPN here. So right now I've never tried to initiate any VPN traffic, so you're not going to see anything show up right away. What we should be able to do is from laptop 0, send a ping across to laptop 1. The first couple might time out while this tunnel is established and we go through ARP and everything like that, but eventually we should be able to ping 192.168.1.10, I believe. Let's double check. Yep, 1.10. And see if this will eventually go through. Okay, so sent for and lost for. Let's take a look at a couple of things. One thing that we might want to do here is to add a route coming from our internal 10 network, telling it how to get to the 192.168.1.0 network. So what I'll do to get that in place is just from config t, we'll do a route where we're trying to get to. So we're going to leave the outside interface. We're going towards 192.168.1.0, and that was the slat 24. And of course, how do we get there? We need to go to our neighbor of 138.247.80.2. So adding that route, we'll need one, of course, on the other side to let them know how to come to us, which that should be already configured for us in this file. So what we'll do now, again, is we'll go back to our laptop 0. We'll try to start a ping again. So let's do this. 92.168.1.10. And there you can see it comes back. So you might take a couple of packets that'll time out right away. I did just briefly test this before showing you the route command. So give it a couple times, it should start pinging. But what we want to look at too is how do we verify the security associations that we need to have. If you go onto any of your firewalls, you should be able to, from your privileged exec mode, just do a show crypto ISACAMP SA. And what you're looking for is basically you have one security association with your peer. It's LAN to LAN, and our state right now is in QM idle, meaning there's really just no traffic going across it, but it is authenticated, the key exchanges have been done, that tunnel is up. Another way to look at this is if you do a show crypto IPsec essay. When you look through this, we look at our packets that we have. Our packets encrypted will keep going up as you keep sending pings across, or if you open up a web connection, things like that. So you can kind of actually watch the counter of how many packets have been encrypted. But all in all, basically, if you configure that VPN the same on each firewall, of course, changing the IPs necessary for things like the peer and the ACL, you should have no problems getting the VPN connection up. So that's all I've got for this one.